It's the only long-term market for which semiconductor companies kick out new product.
The new role of Chief Sustainability Officer needs to be in the design team from time to time.
Customers today are having a similar issue to what they may even had 20 years ago in terms of how do I keep my products alive?
If you're putting your checklist together, give your design team the requirement and enough time to respond to designing for long term.
New regulations, probably one of the most regulated on sustainability now, is the automotive sector.
Obsolescence is never going to go away. You can't make obsolescence obsolete. It's always going to be there, right? Because technology will always look to move on and move on and move on.
Right, hello, it's Jon Barrett here, founder of the Sustainable Engineering Alliance, and I have a real surprise today. This is the second episode of the World Made Better podcast, and we're back with Rochester Electronics, and here we have Paul Green with me and Dan Deisz. Paul, please introduce yourself, your job title, and what's your role within the organisation.
I'm the Director of Sales for Northern Europe, Middle East and Africa. I've been with Rochester for 18 years this year, and I've seen a lot of development in the business through that period. So I manage the team externally for that region. We've got a number of people across that region. Really exciting to see developments in sort of Middle East and Africa, and seeing how that's going to evolve, as well as traditional markets like perhaps here in the UK. So lots to do.
Dan, same question to you. If you could introduce yourself, your job title, job role, and
Absolutely.
what you do.
Thanks, John. My name is Dan Deisz, and I'm the Vice President of Design and Technology at Rochester. And we're the method of last resort within Rochester, and we'll get into that a little further, but that's the creation of new silicon that looks like the original silicon in a fully authorized way. So been with Rochester a little over 17 years. So both Paul and I worked with each other all during that time, and I've been exposed to a tremendous amount of the obsolescence and sustainability challenges that you're talking about today.
And this coincides with the DSEI show in London. So we're in London today. Dan has flown in from the States to be here for this event. And we're going to open the conversation, I think, with Paul. Been at the show today, and you've had a great opportunity to talk to a lot of customers there. So I was just going to ask, just to get the ball rolling, we're looking at the subjects of sustainability, product longevity, durability, keeping electronics in the market for as long as we can. Can you just give us kind of word on the street? What are the trends in the market at the moment in terms of electronics design, manufacturing, and keeping those products healthy and living well in the market? What are people talking to you about at the moment?
You know, it's an interesting question. Thank you, John. I think that customers today are having a similar issue to what they may even had 20 years ago in terms of how do I keep my products alive? Talking to a number of different customers today who are still trying to support programs that are very old. I was talking to one earlier about Tornado. Now, that's been some time since we've obviously had a support over here for that. And I think that, you know, the component world is at an ever increasing pace. And I think that that becomes more and more difficult for those companies that are trying to produce a program for a long period of time, where they simply don't want to go through the exercise of redesign. So it becomes an increasing issue for them as every year goes past. So, you know, there's issues of, and we'll talk about this a little bit more later on, but changes of silicon, changes of packages, manufacturer changing direction, wafer foundries changing nodes, and what does that all mean? And for those customers, they want a solution. They want to try and find something to help them where they don't want to go through that redesign process and the costs involved with that, the resource required for that. So whether it's a packaging issue, you're going from what we call as old-fashioned kind of through-hole product, which is still what they want and still in their boards. But hey, that's what we still need. How do we then get around this? What do we do next? So, the issues that we're seeing today are not really anything too new. In fact, if anything, it's just accelerating in terms of what that's looking for customers as the market goes at a rate.
I've often wondered, the question I often ask is, when will we reach kind of peak obsolescence? Will it ever peak? Is it a forever issue that design engineers need to consider?
I hate to be the purveyor of doom, perhaps here, but obsolescence is never going to go away. You can't make obsolescence obsolete. It's always going to be there, right? Because technology will always look to move on and move on and move on. And by nature of that, you're going to get parts then made obsolete, because today's latest and greatest is yesterday's, so it's kind of like the old fish and chip newspaper. It's great today, but it's going to go. So to your question, are we going to see a peak of that? I don't see that. I don't see that. I think, as I say, and I don't want to be here sort of going, oh, it's all going to be a horrible nightmare. I guess that's why companies like Rochester exist, to be able to help support customers through that. So it's going to be here for a little while, I'm afraid to say.
I'm going to throw a slight curveball question in, which is, give me a clue as to what the market looked like 18 years ago and what it looks like now. If you had to highlight the differences between the markets then and now, sort of technology wise, how would you describe that?
Oh, that's a great question. How have things perhaps changed in that time? Funny enough, we're still supporting customers with the same product that we were probably producing 20 years ago. I think that we've diversified quite a bit in terms of some of those industries as well that we support. So I think traditionally it was a lot of aerospace and defense. I think that it's so much more than that today. It's a high rel product, so it's a lot more. It's medical, it's high-end industrial, it's transportation, who have the similar issues, but I think is expanded. And I think if you look at ones like automotive, it's coming. And I think that when I started, we'd never even think about talking to companies that are producing product for cars. But today, loads of cars have got loads of electronics in, and how are they actually going to support that? So it's a diversifying market, I think, as much as anything else.
That's fascinating. Yeah. So a real change in the, how can we call it, the foundation of the industry sectors that you now work across. That's interesting. And maybe the same question for you, Dan.
Exactly.
What about?
I was getting ready to jump in and say, okay, let's flash back to 2005 and think about the technology back then, and you can say, okay, there really wasn't FinFET from a transistor perspective, so you didn't have the vertical stacking of transistors in the technology, so you didn't have what you've got today. There were many more foundries available for different process nodes, and assembly types. QFN didn't really even hardly exist. And if you just walk it back, then everything was a planar technology. The packaging was still primarily lead frame and trim and form based. Many BGAs on the high end or the performance end of things for sure. But now you flash all the way back to what were the processors, and it was very much a standard. Okay, you're either Intel or your PowerPC or your ARM, just getting going at that point in time. But it was not like it is today, where you've got the GPUs and all the different MCUs and all the different processor types that you've got for specific formatting, and AI wasn't even a thing.
Yeah. Just back to you, Paul. One of the things I was interested in discussing in relation to DSEI and the defence and sort of security markets, that sort of thing, is the product sovereignty. I think is probably the way I describe it. Owning that supply chain. So you've got a full kind of line of trust all the way through. How important is that to that sector? I would imagine it's paramount.
Absolutely. Yeah, very much so. It's so important to know that you've got a robust supply chain that is reliable. You know that the product is going to be good. You can know that traceability levels. You know throughout that whole process that a product that's going to be used in a high-rel application by the prime and go through those different sub-tiers is going to be as good as it could possibly be and is 100% reliable. And so absolutely, it's got to be from a source that you know is to be trusted.
I think that it goes beyond that to where it's not just knowing the supply chain or knowing the pieces of the supply chain. It may actually be bringing the steps of the supply chain inside to control it.
Yep.
And so from a semiconductor perspective, which is Rochester, that means assembly, test, design, reliability, quality, all those steps integrated into our internal control and effectively ensure that supply chain really is under management.
Yeah. So essentially, you're building guardrails around that.
Absolutely,
process.
yes. Yep.
Is that a fair description?
Yes.
Yeah. Okay. Now, my background is design and engineering, and if my readers think like me, what we really want to do is kind of get under the hood of the process. If we're an engineer and we're buying into a service like this to extend the life of a product, or for example, in the aerospace industry, I understand there's a decade-long waiting list for aircraft. So placing orders today for aircraft that won't be built for maybe another 10 years to keep that process in place. Now, those viewers of this podcast, readers of our magazine, they're never really going to have had the opportunity to have a look under the hood of your process. And I thought this would be a really nice opportunity for you, especially down at the kind of coalface of this, to just walk us through that process. How long does it take? How many people are involved? How many steps are there? All of the things that our readers would, I'm sure, love to know and get their teeth into. How does it work?
So I imagine then, a customer's come to us and said, hey, I've got a problem. Can you help with this? Right. So Rochester is quite unique in its model in terms of the different solutions we've got available. So we'll kind of go through a bit of a process. So to begin with, okay, is it active? Is it obsolete? Is it a part we've got in stock? That's a nice, simple, yep, done. Here you go. How many do you want, Mr. Customer, sir? And we've got a lot of parts, right? We've got probably more silicon in stock than any other company in the world. So if it's an obsolete part, we don't have it in stock. Okay, then do we have the die? Do we have the capability to manufacture those parts? Do we have the IP? So everything that we need to be able to manufacture that device to what the customer would need that to be. Again, relatively straightforward. We can come up with a proposal, have a lead time, low MOQ. It's the next step beyond that where Dan then really gets involved in terms of, okay, well, we don't have stock. I don't have die. I really need this part. So our next sort of development, then I pick the phone up to Dan and say, Dan, we might need some assistance with this one. What can we do?
I have joked we are the method of last resort. And just to summarize again what Paul said, no finished goods are available. No wafer die available. Now what?
Okay.
The customer is stuck at that point. I really want to keep shipping this same system. Keep in mind there are 4 major reasons for component obsolescence. A lot of people say a component went obsolete, but they don't know why. I put those 4 as very simply the silicon fab process went away, the package type went away, the tester platform went away, or the revenue targets not being met. Okay? Every one of those 4 give you what your next steps are. But let me take the hardest one first, and that's the silicon fab process obsolescence part of it. The fab process has gone away. Somebody's stuck. Typically, how they're stuck is also important to understand. They either underestimated what their last time buy needed to be. They underestimated then the volume the product continued to have, or they they got continuing demand later or additional requirements later that just extended everything. So that's typically the situation they're in, and they're contemplating, do we have to redesign? Do we go forward with recreating original silicon? So when it comes to me, and if something is portable from one fab process to another, some products are not. Embedded flash products, as an example, they're not portable from one fab process to another. But let's say it is portable. Good example of products that we've done. AMD 486 processor we did for AMD. A TI DSP 3MS20C50. We've done those before with the authorization of the original manufacturer. They hand us the GDS2 database. And that's what's different about design at Rochester. We're starting with the physical design. We're not starting with VHDL, Verilog, and weaving our way with timing constraints and trying to repeat the same timing they had. We're physically cloning the die. We're moving it from one fab process to another, duplicating the die size, duplicating the transistor structure, duplicating the interconnect, and then manipulating it in place to perform the same. So we're doing a physical clone, moving it from one fab process to another. That way, from the end customer perspective, they look at it, they see the same edge rates, they see the same power, they see the same package type if that's available, and they're getting a product that drops in, no software changes at all. And so the process starts with an evaluation of the database, an evaluation of, is this design portable? If we say it is portable from one fab process to another, then we have to worry about the package type. That's the second point of obsolescence, remember, is the package type. Then you weave in the package type, then you have to worry about the test program. Where does that test program exist? Remember, at Rochester, we're also managing those test program sources that came from the original manufacturer, or if none of that exists, we end up having to create it. Just like the GDS2 on simple, older designs, 5 volt, 3.3 volt, those kind of things, we can actually image the design to recreate it, the physical design, and then start the process from there.
GDS2.
Yeah.
Now, some of our viewers aren't going to know what that means.
Yes.
It sounds important.
Yeah.
Yes.
So let's start with that, because you're prompting some questions.
Gerber Design System 2.
Oh, okay.
And it's kind of it is a Gerber file, but it's not a Gerber board file.
Yeah, yes.
It's different. Gerber used to do a format for chip physical design. That got adopted decades ago, probably 40 years ago. There were other physical design formats probably 30, 40 years ago as well. Applicon was one. There's been a streaming file. There's been these different physical design formats, but GDS2 file format has been the ubiquitous physical design format for all semiconductor chip designs for decades.
And still exists.
Absolutely.
The dominant.
Yeah, absolutely.
Yes. That's right. Okay.
Yes.
And when you were talking about moving between fabrication processes, just describe to me what the difference between fab process A and which is now unavailable and fab process B actually is. Are we talking different substrates? Are we talking different machinery? Are we talking different protocols? What's the
different equipment sets exist in different fabs for sure.
Yeah.
That and there's no doubt about that. But the fascinating thing is when you take a look at let's take the oldest digital fab process, 5 volt. Let's just take 5 volt. And some people argue 12 volt is an old digital. Yes, okay, but let's talk with 5 volt because that was millions of part types. 5 volt fab process today is really a 0.35 type of process with thick gate oxide that gets them 5 volts.
Okay.
So your native 5 volts across the whole thing. So that doesn't change. From the pins coming in, that all stays the same. The original fab process, depending on how old it was, 5 volts changed from being a non-planar, kind of sloppy, single layer metal type of foundry process in the not even foundry, contained processes, because there were no foundries in the 70s and 80s, and then gradually developed into being a planar process with CMP processing and tungsten plug vias and those kind of things were all put in place. Even in 5 volt processes, those were put in, but the designs we get could be non-planar 5 volt, and we have to get it to a planar 5 volt. So the differences are going to end up being the back end metal stack, everything from contact up, contact metal 1 via metal 2 and so forth. You look at the difference in the stack height, and you look at the difference at the RCs and all that, but then on the front end is going to be all the transistor structure. you have less to worry about in today's 5-volt fab processes than you do the older ones from a reliability perspective. They're mature, you get high reliability. But now you're looking at tuning the input capacitance to be the same between the original device and the target device by changing the active area around the poly.
Right.
And then you're looking at moving the poly in and out to perform the same from an ID sat perspective, which is saturation current for both the N and the P, and you make that equal out. And now you swap out different contacts and vias because every fab process is different from a contact and via perspective. You do all your equivalence checking, you do all your proving, and then next thing you know, you come out the other end, you have a product that now we develop data in the lab that proves they're electrically the same. They pass the original component test program from the original manufacturer, and here's our lab data that shows up what the I/O edges are. No new harmonics, output edges right matches up. Tremendous amount of not leading edge hard spice analysis and spice work at the transistor level, at the chip level even.
So that's prompted 2 more questions. You mentioned that the newer processes are planar, yeah, lead to a more reliable component.
That's
so
correct.
You're not just mirroring the functionality of that device.
It's a byproduct.
Yeah. Are you making a more reliable device?
Well, we can't really prove that per se because we don't have enough of the original parts to do a full reliability testing that would be needed to prove it.
Yeah.
But I can tell you that with a planar process, you have 100% tungsten plug vias where you get 100% step coverage.
Mm-hmm.
Step coverage is how the metals flow from metal 1 down into a via or into a contact. And the non-planar processes, you looked at it as flowing over the step of what formed the contact or the via. This step coverage was a current limit that was in place in non-planar processes. In planar processes, you've got 100% step coverage, which gives you way higher reliability for the same interconnect. Okay. So there's that aspect of it. But in reality, from a power perspective, which is heat, which is the evil of all semiconductor, you still have C to VDT, which is your VDT, your change in voltage over time has not changed. Okay. So your voltage isn't changing. Yep. And the only thing that you can possibly say might be different is capacitance, but that's only slight. So it really doesn't play in.
Now, you've taken a minute or 2 to describe that process. Okay.
Yes.
It doesn't sound easy.
No, it's not.
So give our viewers an indication of, how many people are involved in this process?
Right.
Is it skill and dexterity? Are there software tools? Do you have bespoke processes
that
allow you to do this that outperform your competitors? I'm imagining you're developing your own tools.
Yes.
Give us a little bit more about that.
Absolutely correct. So when you look at what we do, when we do a reverse engineering, starting with a database and going backwards, there's all the design tools put in place for semiconductor design today are for a forward flow. They're not put in place for a reverse flow. So when I go buy a set of tools from pick a semiconductor vendor for tools, Synopsys or Cadence or whoever, Siemens, Mentor Graphics, any of those guys, they're all our suppliers, but we have to piece together the flow we need from each of them because there's no money to be made by a EDA tool supplier for what we do to go backwards. So yes, you're also correct, and we have come up with proprietary tool sets. Basically, the whole GDS2 editing stack is our own. We created that ourselves so that we can control that with Python, Tickle, and all those scripting languages into the tool set to be able to manipulate the physical design. So it's really heavy on spice analysis, which is transistor level simulation. We do chip level spice simulation, which from a regular semiconductor design perspective is unheard of. People don't do that. first of all, leading edge products, you can't do that. It's too much, too big. You got billions of transistors. You're not going to make that happen. But 5 volt, 3.3 volt, and 1.8 volt, you can do that. With today's compute engines, today's SPICE engines, you can actually punch a full chip SPICE net list into a SPICE engine and make it happen. And so that is how we take a look at it. I joke with customers that documentation, as much as people like it to be reality, the only reality is the chip itself. Yeah. And so when we're replicating a chip itself and we're doing it at the level we're doing, we don't have to worry about the documentation not being right. Because the chip is the chip.
Yes. Okay. Yeah. So even if there was a discrepancy in documentation or there was a lack of documentation, it's the physicality of the device that matters.
And a lot of times we get into a situation where Paul calls me. It's not just Paul. It's every salesperson will give me a call and say, where do we start? What do we have to begin with? And especially if a customer is coming to us with a custom silicon design, an ASIC design that they did, what do they still have of a database? Do they have anything of a database? Or are we stuck with trying to recreate that database somehow or get that original database from their original manufacturer? So it always starts with that exercise. What do they have for an archive? And so from a sustainability perspective, where you're coming from is archives matter. What you archive and how you archive also matters. And we've written a white paper probably 15 years ago now, we wrote it, on design tool independent archiving. Because what a lot of people think about as design community is they think about archiving a design just, okay, IT group over here, take everything in this directory and save it for me. No, that's horrible. Right. Because what you've just done is you've also forced over here, now you've got to mirror the design tool setup that you had. Yes. 20 years ago, which you said earlier, what was that? Windows what? When you go back in time, it's Red Hat what? Yeah. And you got to go back in time, and now you got to repeat the operating system. You got to find that existing tool set. Otherwise, you can't read proprietary tool formats that were the outputs.
So what do you do?
So if you really want to design for sustainability, you also think very carefully about how you archive and what you archive for somebody, not the existing design team picking it up 20 years from now.
Oh, ouch.
Okay. No, it's not so bad.
Okay.
I just told you a design format
Yeah.
that has been ubiquitous for 30 years on semiconductor chip design, GDS2.
Okay.
That's one thing. Another thing is kind of common sense. It's why would you ever archive something with Microsoft Word? No slam on Microsoft, but that's silly to think that 20 years from now, you're going to be able to read the same Word file. Okay. So Adobe Acrobat. So text files. Yeah. Pictures, JPEGs, ASCII. Yes, those are the things you have to think about. Okay. If you really want to design for sustainability and you really truly want to put an archive together that matters, think about the file format. Now think about what are you putting that data on? If you put it on media, how long is that media good for? You better always keep it on spinning disk drives that are RAID, backed up, all that. Because you put it on a media that's static, how long is that media good for?
So how many design teams would you say? What percentage of design teams at the moment who are in this field designing these types of devices and products? How many are archiving to that level of precision?
I would say next to zero, including those design teams at the semiconductor companies themselves.
And is there no standard? Is there no ISO standard?
There is no ISO standard for semiconductor chip design archiving. Now, I will also say, I will also say that design teams may intend or want to do that. Design teams for long-term systems are typically not given enough time to do that, nor are they told that must be a requirement either. Might be because there's no standard. It might be because they aren't given enough time to do it. But I think in reality, the customers we've dealt with over our 17, 18 years here at Rochester, many would like to have that time or would want to have that time, but they don't have that time or they didn't know.
I'm gonna I'm gonna propose something now, because I was going to ask about your design process, but I'm now also going to ask about this archiving, because this is a subject I think we'll have to come back to. This is fascinating. Um, I volunteer. I'll throw in on the side here. I volunteer at an organisation that repairs products, okay, for the general public. And the biggest single problem there is no archive of data.
Right.
You come across a product, you take it apart, there's a barcode, QR code, or whatever, you scan it, you try and find the PCB layout, the bill of materials, just at a very simple level. It's never there because there's no archive process for that. This is obviously many, many layers deeper than that simple archive, but it appears to be ubiquitous across the design infrastructure. That, as you say, there's no standardized way of building that into your design process.
Right.
Now, dare I ask the question, for the tools you're developing and for that type of future archiving process, is artificial intelligence a potential solution? Because it can go out.
Not right now.
No. Okay.
In fact, a good amount of the time it's a little misleading.
Okay.
Because it again, we're dealing with technologies that are much older than AI is, and it doesn't really grasp the concepts of sustainability yet.
Okay.
That isn't the main mission yet. So it might get better in the future, but right now, no, I don't think it's very useful. It's useful in coming up with pieces of maybe the design flow in a quicker way, but as far as solving archiving and sustainability, no, not at all. No. I think it all comes back to what are the requirements to the design team? Are they given enough time to accomplish those requirements? Is archiving part of their requirement? And it also, it'll come back to, and Paul can attest to this, it'll come back to, are they actually given enough time in the design flow to choose more wisely as to which components they use, which semiconductor companies are their favorites? It's obvious who is a long-term sustainability semiconductor company versus who is very short-term. The classic short-term would be NVIDIA, right? They're moving speed of light and trying to absolutely move AI as fast as they possibly can to all markets. That's a horrible long-term sustainment, long-term system choice. Unless you're going to archive everything and stock everything because they're moving incredibly fast. Where Texas Instruments, Analog Devices, ST, Infineon, these guys are in it for the long haul because they have automotive as part of their market segment choice that forces them into thinking long-term already. NXP as well. So NXP, Infineon, ST, TI, and ADI, those are probably the 5 key ones that when you really stop and think about it. Design teams need to be, who are designing for sustainability and long-term, really need to kind of change who their preferred partners are, but then that forces them down architectural choices that may be less comfortable than what they've been doing. And are they given enough time to do that?
Paul, coming back to you, you were talking earlier about the number of options that Rochester has in terms of different services and technologies as customers first come to you. So let's imagine the whole sort of silicon thing is it's a journey, a kind of roadmap, etc. At some point, an OEM manufacturer is going to start that journey with you. Okay. I'm interested to know the sort of percentage of companies really that you can help with phase one, service one, working all the way through to Dan's team, which is the real kind of end of that road where the heavy duty design process kicks in. What is it that what is it that gets the customer to you in the first place? What have they done or haven't they done to start that process with you?
I guess it's they haven't probably planned very well potentially, and that's often very difficult to do. And I appreciate that. So that customer that's come to us with a moment, I need some product. There's a whole backstory to this. And typically, and it's been told to me many times, we come to Rochester when everything's kind of else has gone wrong a little bit. We need your help. Okay, so what is the backstory for this? If it's an obsolete product, our aim is to make sure that we can support that customer in any way that we possibly can. Clearly, the easiest, cheapest, quickest route is from inventory parts we have in stock, which we can help with. Happy days, Mr. Customer, you've got that. And we can sort a lot of issues out for customers with that inventory. So we've got a huge profile of product, and that's easy. That's, I don't know what percentage of that. It's a fairly high percentage. That next stage on from that, in terms of that manufacturing piece, again, it's a relatively straightforward procedure. Typically, we've built many of these different products before. We've got all of the IP and the die, and we can cover quite a lot with customers with that. We've got a relatively low MOQ of just 100 pieces in terms of manufacturing. So we're not high volume. We are used to customers who are building higher applications, typically lower volumes. And then it gets to Dan's cream at the top, I guess, if you want to put it that way, in terms of that solution build. But that could be 10% maybe of what we get to that level. And I guess going back to our initial point about that planning. Now, there will be times in terms of we missed a last time buy. We didn't buy enough. We got some unexpected additional demand that we hadn't catered for. And what we are trying to do as kind of market leaders is say to customers, well, let's do a little bit of planning on what are those real critical parts that you need for your application. Don't look at it too late, because it's often at a point then either we've got no solution potentially, or it could be very expensive, Mr. Customer. And what timeline are they on that they will need product? If we're talking about potentially doing a recreation, you could be talking about 18 months, maybe even 2 years before they're going to be getting fully qualified product for application. So if they need product within 6 months, that's not really going to fly. So let's make sure that communication and that understanding is, how well does the customer even know their own product? What's in that product? Time and time again, we've seen them outsource kind of design or production, and often will lose kind of control of what is important for their devices. So work with companies like Rochester to be able to understand where those pain points may come. We're often misunderstood in terms of the business that we have, and we are not just here to sell components. Yes, we do, but that's not what we're about as a solution provider, as a market leader, to help with customers for that. So plan well in advance in terms of what shape that could look like, because the longer that goes on, the worse it's going to get, the more expensive it's going to get, and the longer it will be potentially for that solution to arrive. So, I would always suggest look at your critical parts list and work with Rochester to enable us to understand, well, what is that technology? Is it a part that potentially is going to be a problem in the years to come by nature of knowing the silicon, the package, the manufacturer, the industry that it's being used with, so that you can try and preempt a little bit from that. And I think something that we've been touching on is a little bit of archiving data, how you kind of make sure you do that appropriately, properly, in the best way to kind of future-proof as much as possible, where you're going to be in 5-10 years if you've got a program that needs supporting for that longevity. So it is a little bit of a journey, and it's a little bit of education as well a lot of the time in terms of what the conversations we have with customers are. So when that customer phones up and says, hey, Paul, can you help me out with this part? There's a kind of big backstory that we need to better understand about how we can support that, but also perhaps what could we do better to make sure that we don't get to that moment, I need product tomorrow.
And what would be obviously the ideal thing is to open a dialogue as early as you can. So even when someone's laying down a bill of materials for the first time, there's no reason why they can't talk to you, I guess. What frequency should you be having those conversations? So what if I was going to advise our audience, this is the type of pulse rate that we should be in contact with an organization like Rochester. They can see the market, they can see the way the technologies are moving, etc. How often should you be having those conversations with a customer? Is it daily, weekly, monthly, twice a year? What's an optimum?
It's kind of hard to put a specific timeline on that, but I would suggest probably is quarterly, because things change at a fairly rapid pace, and increasingly we see last time buys shorten quite a lot. And what used to be kind of a couple of years became a year, became 6 months. And so I think that as often as possible, I would suggest. Daily might be a little bit over the top.
Sure.
But hey, happy to have that conversation if required.
Paul said something I want to jump in on just a little bit to explain for your listeners, is that he said critical parts list. And one of the things that another way to look at critical parts is the closer a part is to system software, the more critical it is. So a processor, a custom chip design, an ASIC, maybe a specialized RF component, these are all very close to the system software. The closer you are to system software from a component perspective, the more critical that component is. And so, one of the things your listeners might appreciate is that there's been several studies about the cost of change, especially when it comes to long-term systems and sustainability. Software changes are an order of magnitude more expensive than hardware changes.
Okay.
And we see this with customers all the time. The entire commercial avionics world, for example, is governed by DO 254 as a hardware change standard, DO 178 as a software change standard. If you trigger a DO 178 event in commercial avionics, it's a nightmare.
Right.
Because now you've got to do everything under DO 254 as well.
Okay.
And so it is a superset challenge when you touch software. And this is typically what our customers want to avoid at all costs, is a software impact. And by critical parts, when Paul says critical parts, share the critical parts list is what processor architecture have you gone with? What kind of specialized components have you chosen? Because those very typically are then software driven.
Okay. Because I'm thinking about a bill of materials now, and I'm thinking about the order of the components on the bill of material.
Yeah,
and I'm thinking to myself, what's the probable order of those components? And normally it's just going to be cost or something like that. It's not going to be how close is that device to the software.
Correct.
But it could.
Sometimes they correlate. Sometimes they don't.
Okay. Yes.
And so you just have to be aware of when we talk about critical parts list, it's really those that come closest to obsoleting a system with no choices.
Yeah.
The end of the line for that system. What parts are those on the BOM that are going to absolutely prevent me from shipping anything?
Yeah.
And there are many things that we try to do as Rochester to extend the life of a component, including die wafer banking, where we have billions of die under storage, investing in our own assembly capabilities and being able to do that assembly. And then, of course, lastly, my design team to create new silicon that drops in exactly where the old silicon was in a fully authorized way. So a great example, I'll give you a product example and then let you move on. Sorry. But, Intel, many decades ago, created a standard product along with Bosch. And it was the very first CAN device. Okay, CAN as a communication standard got adopted by automotive, got adopted by heavy equipment manufacturing, Caterpillar, John Deere, and so forth. And CAN was really pretty ubiquitous in industrial control machines. And so Bosch came up with a standard implemented by Intel, and then Bosch came up with their own part, and now Intel and Bosch are both out of it. Rochester is working on working off of Intel die. We had hundreds of thousands of Intel die, so we were assembling and testing using the original Intel test program. And now my design group is recreating it. But we've also invested in the 44 PLCC package type so that we can assemble it. So it is a combination of investments that have kept that product alive from a Rochester perspective, and that is a software impacting product. So that's kind of an example of a critical product where Rochester can see it's a critical product for certain customers, and we invest in the assembly side, we invest in the design side, and we invest in keeping the test program alive from Intel. And now we put the whole picture together, and we're able to keep customer systems going that use that old CAN interface. So it's a combination of all of that we're able to do, real manufacturing, not just managing an OSAT supply chain and making phone calls, but actual have assembly in-house, test in-house, qual in-house, rel in-house, design in-house, all of this to keep a product going.
That's a fascinating example. I was unaware that you were doing that. So if you take that model, obviously CAN bus, like you say, ubiquitous across automotive and other industry sectors, so a big market. If I was asking you to second guess, where would your next big investment like that be? What do you think that might be? Dare I ask?
We already know. So, we talked about software impact, and that is where we're investing first. And software impact, we're making a major investment, have made it in NXP PowerPC processors. So there's a MPC 565, 566 that are being used by long-term system companies. We know that already, and we have work to deal with NXP to ensure that product can keep alive by doing wafer fabrication still at NXP with all of the die wafer coming to Rochester under storage. Then we're creating our own package for that. And then we're doing the test for that on the same exact tester platform NXP used for the product. And this is still a product in use today at some key long-term system companies that we're engaged with. And we're investing many, many millions into this product line portfolio to keep it going for decades to come.
And those types of, how can I put it, availability projects, is there a list of those? Can I find a list of?
You will see Rochester kicking out notices of specific products that we've invested in. Absolutely.
Yeah.
But all of this comes with partnership with the original component manufacturer and understanding when they are going obsolete, and it ties into long-term system companies that we're engaged with. So when you talk about when's the best time to talk to Rochester, I'm going to say it's once a month or no less often than once a quarter, because those engagements with those semiconductor companies are constantly evolving, constantly changing, and they're constantly looking at us at a way to have an easy obsolescence for them rather than a tragic or a rather impactful emotional event.
Yes.
To be more of a soft end of life rather than a hard end of life. That's it. Now you have to deal with it all, Mr. Customer. So anyway,
I was going to say, just if I can just add on that, I think, more and more we want to be kind of reactive to what our customers really actually want. So we're in the middle between suppliers and customers, right? Suppliers are doing their thing and customers are doing theirs. And we're kind of wanting to make sure that we are supporting both sides of that. So, hey, Mr. Customer, what actually are the key things that you would like us to be able to do? Because we want to take that forward, and things like the PowerPC has been a part of that, where customers time and time again have said, hey, we need some support of this. And that's the direction that then we've taken forward. And I think that's really interesting. And I wanted to add another thought to something that I had earlier about how can we help the customer a little bit more about when it comes to these discussions. A lot of customers will use third-party companies or platforms. They'll see Is it active? Is it not recommended for new designs? Is it obsolete? Whatever. And they're great, right? But only tell really half the story. And you know what? I absolutely would say the best thing to do will be to speak to us rather than rely on algorithms in some extent, because it doesn't say the whole thing that's going on within that industry. And I think it's important just to say, although they're great, there's a lot of things going on that isn't necessarily going to bring to the picture. So, if there's a part that's currently shown as an active part, well, in actual fact, it could be going end of life next week, because we know that, because we live and breathe this industry day in, day out. It's something that we could have that dialogue with customers. Interestingly also is, if a part has gone end of life, it might be something that we can actually provide the previous iteration rather than this one. Lots of things that might be able to stimulate an idea of, well, you know what, actually we could support it in a different way, Mr. Customer. Have you tried thinking about looking like this or like that? Or there's lots of different sort of variations that potentially you could bring just by actually having a conversation and some dialogue on a regular basis.
And bomb tool health tools, bomb health tools, none of them are owned by a semiconductor company. So where are they getting their data? And if you're a semiconductor company who's doing your own manufacturing and you're extending the life of products, we're going to know trends before a bomb health tool will. We are talking to Amcor, we are talking to ASC, we know when those assembly types are disappearing. That becomes incredibly important in how we invest for assembly going forward, what we invest in to keep products going. So weighing all that in, we're going to have unique insight. And it's just because we're in the middle of it, as Paul says, between the semiconductor OCM and the end customer. And we're just really trying to enable that end customer to keep shipping the same system that's proven, they got no software changes, and move on.
We're getting to the end of this podcast now, and Paul, I wanted to throw a question at you and also Dan, which is, could we leave our viewers with a kind of checklist to get them into this system as such, thinking about this as a process, thinking about this as a journey, while they're sitting down designing a product today in the here and now that will be in the market in 20 years' time? How can we put a checklist together that starts to get them thinking about that sustainability and longevity? Just maybe 5 or 10 things they can do. What would your advice be for a checklist like that from a customer's perspective, and then down from a technical perspective?
Yeah, so I know Dan will cover it from a kind of a technical avenue, I think, but from my sort of commercial hat on with customers, I would certainly make sure that they're looking at the technology they're going to be using. They're going to be looking at manufacturers they're looking to use. They're going to be looking at the sort of packages that they're going to be in. Importantly, looking at those that are going to have that sustainability for the future, who has got sort of good recognition for supporting that long term. That's potentially quite difficult when you're looking at a current design today, and often your mind is in today. And very much appreciate where would that be in 5-10 years is not always something that's going to be in the forefront of their mind. So which of those parts they're designing in today is going to be one of the critical parts? You're not talking so much about a logic type of proprietary jelly bean sort of stuff, but the processor or the ASIC or the FPGA or whatever that sort of technology that's going to be the brain of that board is going to be really, really important. I think that if you look at memory is often it's a product in its own little bubble that moves at a pace. Where are they going to go with that? What is the potential longevity of the technology they're going to be looking to do? So I think that it's them, and I know Dan will touch on what the software implications are for those them parts, and I think that's really important in terms of if you look at it this way, is the technology, the manufacturer, proven manufacturer that's going to have long-term support potentially. Is it going to be, what sort of package are you talking about? It's kind of things that you can do as best as you can to mitigate the risk. You can never see into the future. We haven't got our crystal balls in front of us, but mitigating that risk as best as possible. And that's the advice, I guess, that Rochester can help try and provide.
Okay. Just on the brands, a quick aside on that. How does a design engineer determine a brand's commitment to sustainability and longevity? Is there a database somewhere? Is it the conversation? Do you know more about that than they do? Should we be building that database? Maybe we should. Is there an easy way of achieving that?
Yeah, no, there's no easy way, first of all, but you have to look at the track record of companies and then be very careful about whether that company has recently completely changed direction.
Okay.
A great example of a recently completely changed direction is on semiconductor. Okay, they certainly have gone through a ton of changes compared to what they were 3 years ago versus now. Would you choose them as a long-term available partner? Maybe, but now it's maybe, where before it was definitely.
Okay.
And so some people move between spaces and they become, but you can also look at look, there are three major markets that semiconductor companies respond to. Okay, there's artificial intelligence, there's portables, and there's automotive.
Okay.
Those are the three biggest markets. It's about 75% of the market. Okay. And the only one that's long-term out of that is automotive.
Right.
So you really have to look at who is, for long-term systems, who is serious about automotive.
Right.
Because that's the only market that moves the semiconductor companies strategically and causes them to introduce products for that market.
Okay.
It's the only long-term market for which semiconductor companies kick out new product. No other long-term market do they kick out new products for it.
Okay.
That is a long-term system company. So if you look at, there's no specific product kicked out for commercial avionics anymore.
Yep.
There's no long-term product kicked out for trains.
Okay.
Because the market simply isn't big enough to warrant a new product introduction. And a new product introduction today, $500 million, $750 million, depending on what the product is, but one that touches software is about that much money in the latest technology. So you kind of look at where you're, I'm going to put in a plug for, if you're putting your checklist together,
Yep.
give your design team the requirement and enough time to respond to designing for long-term.
Okay.
Design teams today are never seemingly given, they're given the goal, but not the time. Okay. And they're said, oh yeah, this system's going to be live for 20 years, but you have no time. And sorry, I bid this system off to customer X that we only have 3 months of development for you. And so when they get crushed on the development time, what do? They choose something they've used before, which immediately sets you back in architecture.
Yeah. Okay.
That is what happens in long-term system companies today.
Yeah.
Is the design team is squished in time. They're not given the goal and the time of, hey, you cannot have changes in 15 years, 20 years. What would you do differently if you couldn't have any changes? And here's the amount of time you're now given to do it. It changes the perspective. And I would say anybody that's planning a new product that is going to be around 20 years, please make that a requirement and give the design team time to respond to that in such a way that they can align potentially with automotive components used. And this includes the military market. This includes aerospace. This includes all that, because they're not doing enough of that. Instead, they keep falling back to, well, this is what I did last time, and this is all the time I'm given, so this is what I'm going to do now.
So automotive is a telltale.
Correct.
Okay. So I'm going to put that down as checklist 5, which is keep an eye on auto because it's a telltale.
Yes,
so
it is.
Good idea. Okay. And finally, from what you were saying there in terms of thinking forwards rather than thinking backwards, in terms of architecture, I wonder if this means that the new role of Chief Sustainability Officer needs to be in the design team from time to time, especially right at the beginning.
They have to be, I think.
That
Yeah.
thought
Definitely.
process.
If you're
Yeah.
making a product that's going to have longevity of multiple decades, surely that's got to be within that
Right.
design phase to be able to be able to support that. Yeah, it kind of seems obvious, doesn't it?
Right.
But today that doesn't really exist.
Because, from the Alliance perspective, we're looking at regulation, standardization and compliance, etc. There's new regulation in the EU, which is eco-design for sustainable product, product passporting. The idea you can just scan a QR code on a product and it's going to have everything you need from the past and into the future. CSRD, which is the Corporate Sustainability Reporting Directive. So that's board level commitment to sustainability. New regulations, probably one of the most regulated on sustainability now is the automotive sector. And so, maybe following this, we can take a deeper dive into how some of that regulation would
I
form
think
that.
package type is another thing right now that we talked on previously, but I want to emphasize again. If you look at all lead frame packages, semiconductor lead frame packages that require trim-informed tooling today, they're all going away. It's a question of when, not if.
Okay.
And if you're choosing a product that has lead frames that need trim-inform, and curved leads that bend down on the board and they surface mount and all that, you should stay away from that.
Okay.
Everything should be BGA, QFN, if at all possible.
Right.
Because that is a sustainable package where there simply isn't enough volume driving trim-informed tool packages anymore.
Yeah.
And while Rochester's investing in a few of those, we're not going to have all of those. And many of those are just simply going to go away. Your TSOPs, your SSO, your SOICs, your quads, PLCCs, we've invested in some of that, but it's selective. And PLCCs we got covered, but it's very selective. And it's something to think about if you're architecting and choosing a product that's on a lead frame that's going away. There's no BOM tool going to tell you, hey, you chose something that's going away, because it's just going to happen with ASE and Amcor, who are the largest assembly houses in the world, are just going to say, we're done.
Right.
Then what?
Yes.
So anyway, that's my last thing on my list.
Right, well, we'll conclude there. We've got a fantastic checklist there. I'm going to write this up because we need to put this into words as well as podcast. And all I can do is say thank you very much for making your time available. I know you're very busy today with the exhibition. You'll be busy for the rest of the week, and I hope to catch up with both of you subsequent to the show to find out any more things you discovered from customers and technologies alike. So thank you very much, and have a great show.
Thank you.
Pleasure. Thank you very much.
Thank you.